Just I'm sharing the screen. So we completed with which topics in the last class? Uh, can anyone say?
Registers. Registers.
Registers we completed. Okay, registers we completed. So those are CISO, CIPO, PISO, PIPO we completed. So next
Yes.
topic is frequency dividers. Okay, what are these frequency dividers? We'll see. Okay, so frequency dividers divided by n. I think my screen is visible. Yes, give response.
Sir, it's visible. We can see.
Yeah, yes. So see here, this is like with a D flip-flop, you can design frequency divided by 2 circuit. Okay, how we are designing frequency divided by 2 means this is the master clock. Okay, this is the master clock. So here Q bar is connected as the input to the D input. Okay, so what happens first clock cycle here this is the time period, no? So total time period of the clock. Okay, so total time period. This is the time period of the clock. Okay, so let us take this is active means a positive edge trigger. Okay, positive edge trigger means what? During the passage of only the output will change. Okay, so first what happens? Initially, what happens? Initially, Q is zero. Okay, so initially Q is zero means what happens to Q bar? Q bar becomes one. Okay, Q bar becomes one, and if Q bar becomes one, Q bar is connected to what? D. Okay, Q bar becomes connected to D. Okay, so this Q bar is connected to D during this passage of clock. During this passage of clock, what happens? This D is connected to Q. Okay. So during this passage of clock, what happens? This Q becomes 1. Okay. As Q becomes 1, what happens? Q bar becomes 0. Okay. Complement. That means this becomes 1 means this becomes 0. As this Q bar is connected to D, so D is also becomes 0. D is also becomes 0. Okay. During next clock edge, what happens? Next clock edge, okay. So here next clock edge, what happens? Here this is 1, and this is 0, and this is 0. Okay. So this clock edge is completed. During next clock edge, what happens? This 0 is connected. D is connected. D is connected to Q. Now next clock edge, first clock edge is completed. Okay. So first clock edge is completed. During second clock edge, what happens? Q becomes 0. As Q becomes 0, what happens? Q bar becomes 1. Q bar becomes 1. And D becomes D becomes also 1. Why? Because Q bar is connected as the input to the D, no? So Q bar is connected as the input to the D. Okay. And during the third clock pulse, okay, during the third clock pulse, what happens? This is the third clock pulse. So initially this is 1 and 0, 0. Again, this 0 will come here, this 1 will come here, and here this is 1. Okay. At the third clock pulse, okay, at the third clock pulse, what happens? Here this becomes 1. This becomes 1. Okay. Why? Because D is connected to Q, no? So D is nothing but sequential buffer. We already seen like Qn plus 1 equal to what? D. Okay. So whatever the D next state value, whatever the D input you are getting at the next stage. Okay. So this is 1. As this is 1, what happens? Q bar becomes 0. So Q bar is connected to D. So D becomes what? 0. D becomes 0. Okay. During fourth clock pulse. During third clock pulse. During fourth clock pulse, what happens? This is first clock pulse, second, third, fourth clock pulse. Okay, at fourth clock pulse, here first clock pulse, this is 1, 0, 0. Again, this 0 will come here. This becomes 1, and this becomes 1, and this is 1, 0, and 0. Next clock pulse. So as D is 0, it is come to Q. Okay. As Q is 0, what happens? Q bar becomes 1, and D is also 1. Okay. So here, what is my clock period for clock? This is T. Okay. So basically, this clock period, it becomes what? 2T. It becomes 2T. Okay. So let us take T dash. Okay. This is nothing but T dash. Okay. So normal clock period is what? This is clock cycle. This is my clock cycle. So what happens to T dash? T dash equal to 2t I am getting. Okay, T dash equal to 2t. So we know that frequency is reciprocal of time period. Okay, so that means this is the normal frequency of my clock, master clock. And let us take f dash. F dash equal to what? 1 by t dash. So if you substitute t dash equal to what? 1 by 2t. So 1 by 2t means f dash equal to 1 by 2 into 1 by t. Okay. So 1 by 2 into 1 by t means what? So I am getting f dash equal to f by 2. Here what happening? Frequency is dividing by 2. Frequency is dividing by 2. Do you understood the operation how the we are generating the clock divided by 2 circuit? This is generated clock divided by 2 circuit. Is it fine? Do you understood?
Yes, sir.
Okay. Okay. Next. Any doubts or any queries? Shall I move forward? Okay.
Yes, sir.
Okay. Next you see. So here to generate the clock divided by 2. So first you need to calculate. Suppose let us take the master clock is how much? 1 nanoseconds. Okay. So frequency equal to how much? So that means 1 by 10 power minus 9. So 10 power 9 means you are getting the frequency is 1 gigahertz. Okay. Frequency is 1 gigahertz. So clock frequency by 2 means what? Time period becomes what? 2 nanoseconds. Okay. 2 nanoseconds means 1 by 2 into 10 power minus 9 means clock frequency is divided by 2. So here 1 gigahertz, you got the frequency as 1 gigahertz. The frequency is divided by 2. So 1 by 2 gigahertz. So the frequency becomes F equal to what? 0.5 gigahertz. 0.5 gigahertz. The frequency is divided by 2. Okay. Frequency divided by 2. Okay. This is generating your clock. Okay. And suppose I want to, so our agenda is you need to divide the F by N circuit where N is odd number and F by N circuit when N is even number. Okay. And clock frequency F by N when suppose like if it is a decimal number. Okay. So basically, counters will use as a frequency dividers. Okay, counters will use as a frequency divider. Suppose if I want to divide frequency divided by 3, okay, which counter will use mod 3 counter? Mod 3 counter. So if I want to divide f by 5, okay, so which counter will use mod 5 counter? F by 7. F by 7 means I will use mod 7 counter. Okay, similarly, if I want to use f by 2 circuit, I will use mod 2 counter. Okay, f by 4 circuit, I will use mod 4 counter. Okay, counter we already discussed, no? Any doubt in this counters? F by 6 means mod 6 counter. Synchronous and asynchronous counter we already discussed, no? Give response. Do you have idea about the counters, no?
Yes, sir.
Okay, next you see. So here, if it is like frequency divided by n, so if there n is a odd number, so you take n equal to 3. Okay, so n equal to 3 means here this is my expected waveform. Okay, normally here if you see the time period, so that means time period. This is t. Okay, this is my time period, and this is one my time. This is my one more time period. Okay, so there is a duty cycle. What is duty cycle? Duty cycle equal to T on by T on plus T off. This is my duty cycle. Okay. T on by T on plus T off. Okay. This is my duty cycle. So that means here what I am getting T on, this is one, here 2T. Okay. So this is means on for how many clock cycles? It is on for one clock cycle. And again, 1 plus half for 2 clock cycles into 100. So what is the duty cycle you are getting? 1 by 3 into 100. This is 300. 33.33% duty cycle you are getting. Okay. This much of duty cycle you are getting. Okay. And next. So here, uh, so in order to get 50% duty cycle, what I need to do? Okay. So here what I am doing, I am using mod n counter, that is n equal to 3. N equal to what? 3. N equal to 3. Okay. N equal to 3. Okay. So n equal to 3 means if it is a mod n counter, From where to where it will count? 0 to n minus 1, no? 0 to n minus 1 it will count. Okay. So here mod 3 counter. So mod 3 counter means it will count from 0 to 2. Okay. So what is the sequence? 0 0, next 0 1, 1 0. After that it will come to the initial state. Okay. So here if you see, so this will be off for how many clock cycles? I need to check for this Q1. I need to check for Q1. So this will be off for how many clock cycles? Two clock cycle. This is on for one clock cycle. Okay, two clock cycle. This is off. One clock cycle. This is what we say on. Okay. So here if you see, uh, so if you if you draw the diagram, what you are getting? This is means this is off for how many clock cycles from here to here? This is one clock cycle. Let us take this is one clock cycle. From here to here, one clock cycle. Okay. And here to here also one clock cycle. Okay. So from this, if I see the diagram, this is off for how many clock cycles? Two clock cycles. And this is on for how many clock cycles? Three clock cycles. So you are getting T out equal to 3 into T. Okay. But here, if I want 50% duty cycle, it should be on for how many clock cycles? So 3 by 2. 3 by 2 means what? 1.5 need to get. Okay. So it should be on for 1.5 clock cycles. Okay. And it should be off for 1.5 clock cycles. 1.5 clock cycle. Okay. For making this, what I am doing, I'm using negative edge trigger D flip flop. Which I am using negative edge trigger D flip flop. If I use this negative edge trigger D flip flop, I can alter the frequency by how much? 0.5. Here 2 is there now. So 2 is there. So here 1 is there. So from this I can alter zero point 0.5 so that here what I am getting, this will be on for 1.5. Okay. So this will be on for 1.5. Okay. And this will be on off for 1.5. So that I will get 50% duty cycle. My main aim is to convert my 33.33% duty cycle to 50% duty cycle. For this, I am making that variation. Okay. So see here. So this is Q1. Q1 is nothing but what? This is the output of mod 3 counter. Okay. So I need to this one. This is off for how many clock cycles? Two clock cycles. This is on for one clock cycle. Here also two clock cycles and one clock cycle. Okay. So here duty cycle is what? Not 50%. Okay. You need to make this as 50%. So I need to alter this frequency by how much? 1.5. Okay. For this, I am using this D flip flop. Okay. Negative edge trigger D flip. Which one? This is nothing but negative edge trigger. Okay. Clock is negative edge trigger. D flip flop I'm using. D flip flop. Okay. Negative edge trigger D flip flop means here you see. So uh, Q1 is given. Here you see negative edge trigger D flip flop means here this is negative edge trigger. Okay. Negative edge trigger. This is nothing but negative edge trigger. Okay. So during this negative edge trigger, whatever, so this is nothing but Q2 output. Q2 is the output of what? Negative edge trigger D flip flop. Edge trigger D flip flop. Okay. Edge trigger D flip flop. So here if you see here, so during this state, whatever the input is there, you are getting. D is nothing but sequential buffer, no? Whatever the input is there, that you are getting. Here 0 is there, you are getting 0. And during this negative edge trigger, so till negative edge, this will be same only. Here you are getting 0. And during this negative edge trigger, see here. So that means here this output is 0. Output is 0. When it will change, it will be 0 only. When it will change the state, during this negative edge only, this output will change. Till that position, this will be 0 only. Okay. So during this negative edge, that flip flop will activate. Okay. So here it will, that means during this negative edge, this input is 1 means you are getting 1. Okay. So again, this flop changes. It will be 1 till next negative edge only. Okay. Till next negative edge, it will be 1 only. Okay. So during this next negative edge, again it becomes 0. Okay. and this negative edge anyway, this is 0 only, it will be 0 only, and till next negative edge, so it will be 0 state only. During this next negative edge, it becomes 1. Okay, so if you add these two, so if you connect with an OR gate, okay, if you connect with an OR gate, so here this is nothing but OR gate, we are connecting with an OR gate. Okay, when you connect with an OR gate, what happens, anyway 0 0 means 0, again this is a 0 only, 0 0 0, and 0 here 1, 0 1 means what, 0 only, here 1 1 0. Okay, 1 0 1 0 means what, here you are getting 1, here also you are getting 1, here 0, here 0, and here this is 1, no, so 1. Okay, so that what happens, this is one time period and this is one more time period. Okay, uh, from here to here, from here to here if you take, this is one time period, one second. I'm altering the frequency by how much, I'm altering the frequency by, see here. So this is one time period, passage, okay, and this is one time period. Okay, so this is one time period and this is one time period. Okay, so from here I can say that it is on for, not, you need to take from here, 1.5 time minutes, it will be off, and 1.5 time minutes it will be on. Okay, so that you will get how much duty cycle. So duty cycle equal to what, duty cycle equal to T on by T on plus T off. So this is equal to what, 1.5 divided by 1.5 plus 1.5. So this is a, you are getting 1.5 divided by 3. So this is a, so 50% you are getting duty cycle. Like this, you can alter the frequency by 50%. Is it fine? Do you understood how I am making the frequency divided by 3? Any doubts, any queries in this? Shall I move forward? Hello, I am audible. Yeah. Anyone? Give response
Yes, sir. You
so that
are
I,
audible.
is this fine? Shall I move forward?
Yes, sir.
Okay. Next you see. So next, frequency divided by 5. Frequency divided by 5 means, now you tell me. So this is off for how many clock cycles? 4 clock cycles. Okay, this will be on for how many clock cycles? 1 clock cycles. Okay, so that means, if you want 50% duty cycle, okay, frequency 5 divided by 2. Okay, you are getting 2.5. Okay, so that means T should be off for how many clock cycles? 2.5 clock cycles, and T should be on for how many clock cycles? 2.5 clock cycles. But here you got off for 4 clock cycles, and it is on for how many clock cycles? 1 clock cycle. Okay, so that means, what I can use, so here in this, I can use, one
You
negative edge trigger D flip flop, negative edge trigger D flip flop, that will alter the frequency by how much, zero point 0.5 seconds, and another positive edge trigger D flip flop, positive edge trigger D flip flop, that will alter by frequency by 2.1 second. So that means, zero point 0.5 plus 1. Okay, again already 1 is on state is there, 1, you'll get 2.5. Okay, anyway, mod n counter means, mod 5 counter you are using. Okay, but the duty cycle is not 50%. To make this as 50% duty cycle, here what I can do, I can use, this is what, passage of D flip. This is positive edge trigger, positive edge trigger D flip flop. Okay, so positive edge trigger D flip flop, this will alter the frequency by how much, 1 second. And this output is given to again a negative edge trigger, negative edge trigger, negative edge trigger D flip flop. Okay, this will alter the frequency by how much, zero point 0.5 seconds. Okay, anyway, this frequency is 1 for T on, so now T on will be altered by how much, 1 plus 1 plus 0 0.5, this is 2.5, 2.5. So this is given to an OR gate, you are getting F by 5 circuit with how much duty cycle? 50% duty cycle. 50% duty cycle. Okay. So, like if I want to optimize this circuit, so in order to see the Q2, just observe Q1. Okay, just observe Q1. So this is off for how many duty cycle, how many clock cycles? Three clock cycles, and this is on for how many clock cycles? This is off for three clock cycles, and this is on for two clock cycles. So we can alter the frequency by how much? 0.5. So in place of using this two D flip-flops, I can use one negative edge trigger D flip-flop. Negative edge trigger D flip-flop. Okay, negative edge trigger D flip. See here. So I can optimize this one with the so Q1. Okay, Q1. So Q1 means what? For Q1, I apply negative edge trigger D flip-flop. Negative edge trigger D flip flop. So if I use negative edge trigger D flip flop, what happens? T off for how many clock cycles? If you observe this table, T off is for three clock cycles and T on is for how many clock cycles? Two clock cycles. Okay, so I can alter how much? 0.5. Okay, I can add. Okay, I can alter so that I'm getting 2.5 for off, 2.5 for on. So that I will get the 50% duty cycle. Okay, 50% duty cycle. This is nothing but F by 5 with 50% duty cycle. Okay, so what is the conclusion? So we need to include the mod encounter, and if it is a positive edge trigger D flip flop, we can alter the output by how many clock cycles? One clock cycle. If it is negative edge trigger D flip flop, we can alter the output frequency, output by how much clock cycle? Half clock cycle. Okay. Need to choose mod encounter having the frequency of how much? F by n. Okay, and less alteration is required. Okay, that I explained now with hardware optimization. Alteration is required for hardware optimization. So that means this point less hardware is required means I told you like F by 5 in order to choose this Q2. Okay, in order to choose this Q2 we need two flip-flops. Okay, so the hardware complexity is increasing. So in order to choose Q2, what I am choosing Q1. When I'm choosing the Q1, what happens? Only one flip-flop is required. Negative edge trigger flip-flop is required. Okay, you need to see for optimization also. Okay, like that. And next, this is F by 7 circuit. F by 7 circuit means this is off for how many clock cycles? F by 7 means you need to use which counter? Mod 7 counter. Okay, it will count from 0 to 6. After that, from 6, it will come to the initial state. Okay, see here, this is 0 and this is 6. After 6, it should count to the modern counter. I told you, modern counter. It will count from where to where? 0 to n minus 1. After that, it will come to the initial state. Okay, so it will be off for how many clock cycles? It is off for 4 clock cycles and it is on for 3 clock cycles. Okay, so 7 by 2, if you want 50% duty cycle, 7 by 2 means how much you are getting? 3.5, no? So that means you need to alter the output frequency by zero point 0.5. For this, what you need to do? You need to connect a negative edge trigger D flip flop. Negative edge trigger D flip flop. Okay, so that means when you connect this one, this will alter the frequency by zero point 0.5 seconds, zero point 0.5 clock cycles, so that you are getting 50% duty cycle. Okay, so duty cycle equal to what? 3.5 divided by 3.5 plus 3.5 into 100. So 1 by 2 into 100, you are getting 50% duty cycle. 50% duty cycle. Okay, this is about frequency divider for 7 F by 7. Okay, if it is F by 2, see here. This is off for one clock cycle and this is on for one clock cycle. So no need to apply extra circuitry. Okay. So this is off for how many clock cycles? One clock cycle. Okay. One clock cycle. This is off. Okay. This is one clock cycle. Okay. And next, this is on for how many clock cycles? One clock cycle. Okay. So one clock cycle. This is on. So directly you are getting 1 by 1 plus 1 into 100. This is the duty cycle. Okay, duty cycle. So you are getting 50%, 50% duty cycle. So no need to apply any extra circuitry. Directly you are getting Q naught with 50% duty cycle. Okay, this is even number. Frequency divided by what? Even number. Previously we seen the odd number. Now we are seeing the frequency divided by even number. Okay. Next you see frequency divided f by 4 circuit. F by 4 circuit also. This is off by how many clock cycles? 2 clock cycles, and this is also on for 2 clock cycles. Anyway, extra circuitry is not required. During 1 clock cycle, 2 clock cycles, this is off, and during these 2 clock cycles, this is on. Okay, so that means T out equal to what? T out equal to 4 into T in. Okay, so so duty cycle is 2 by 2 plus 2 into 100. You are getting 50% duty cycle. 50% duty cycle. Okay, this is frequency divided by 4. Frequency divided by 6 means what? If you observe Q2, if you observe Q2, this will be off for how many clock cycles? 1, 2, 3, 4 clock cycles. Okay, and this will be on for mm, this will be on for 2 clock cycles. Okay, so that means I need to alter the output frequency by how much? 1 clock cycle. Why? Because 6 by 2. So it should be on. T on should be 3 clock cycles, and T off should be what? T off should be 3 clock cycles. Okay, I need to alter by 1 clock frequency. Okay, 1 clock cycles I need to alter. So which one I'm using? Positive, positive edge trigger, positive edge trigger, D flip flop and use. So that I can alter the frequency by how much clock cycle? 1 clock cycle. You see here. So this is Q2. Okay. So Q2 is not 50% duty cycle. So how much of duty cycle? That means here if you see this is on for how many clock cycles? This is off for 4 clock cycles. Okay, and next this is on for how many clock cycles? 2 clock cycles. Okay, this is passage of clock. Let us take this is passage of clock. Okay, this will be like passage of clock only, and passage of clock. Okay, and next, so next Q3 is what? Q3 is nothing but this is acting as the input for this passage of positive edge trigger D flip flop. Q3 is nothing but output of passage D flip flop. Okay, so during the passage only it will change. See here. So during the passage only, whatever the input 0 means 0 you are getting, and here 0 means 0, and here also 0 means 0. Here you are getting 0 means 0. Okay, but here what happens? Here 0 is over. After that, mm, it will be like 1 second 0. Mm, mm, okay, it should be on for 3 clock cycles, and it should be off for uh, okay, okay. So it will not change. Okay, till negative next positive it will be 0 only. Okay. Anyway, here it is changing, but it will not change. Again, during this passage, this is 1 means what? This is 0 only. This is 1 means again it will be 1. So it will be 1 for next passage only. Okay, next passage it will be 1 only. During next passage, this becomes 0 means it becomes 0. Okay, so like this I will get the waveform. Okay, so next what I need to do? I need to add. Okay, so anyway, I need to connect with an OR gate. Any one of the input is high, the output is high. Okay, so here 0, 0, 0, and here if you see, this is high. This is high means what? This one becomes 1, and this is 1. Okay, this is also 1. Okay, so if you see, this is you need to calculate from here. This is low for 3 clock cycles, and this is high for 3 clock cycles. So what is the duty cycle? Duty cycle equal to T on by T on plus T off into 100. So this is what 3 by 3 plus 3 into 100. You are getting 50% duty cycle. 50% duty cycle. Okay. So like this, we can design the frequency divider by 6, and that's it. Okay. So this is about frequency divider circuit. Okay.